But when you think about other situations that you can be asked on the interviews, analyze and think broadly and try to be reasonable, right? But of course you have to have some knowledge. So this is a very frequent question on the interviews: boundary testing. Decision table. Decision table is yet another test case optimization technique that allows you to handle testing of the systems where you have multiple parameters. And based on the combination of those parameters, the output of the system or the outcome of your test flow will be different. So I will give you a very simplified example. Again, you can Google for decision tables. You will find maybe other examples. But this is the example I chose. This is the decision table. And it describes the application which calculates the payroll for the employees. And there are two types of employees. S means salaried employees, which is full-time employees. H means hourly employees or contractors. So the salaried employees, they are paid on a yearly basis, right? They have salary. And hourly employees are paid by the hour work. Those are contractors. Also, based on the number of hours that person works in a week, they have different, the program produces different results or different documentation that needs to be filled out. So basically we can have three scenarios. One is when people underwork, right? So when they don't have overtime or they got sick or whatever, they didn't feel well and they didn't come to work, then we have them work less than 40 hours. There is a normal working week, which is 40 hours. And there may be overtime when there is a release, coming, and we are overwhelmed with the testing activities. We may need people to work more than 40 hours. You put all this data in a table, and then when you look vertically, based on the combination of the employee type and the hours worked in a week, your system is supposed to give you different results. And if you look at this, you have these 6 test cases, and they pretty much test all the positive, functional flows that you may have. Of course, this is simplified examples. Real-life examples may have different factors in it, but it may be as simple as this one as well. So when you have salaried employees, and that guy works less than 40 hours, we pay base salary to him because he has coverage of the sick days, 10 sick days. Of course, it assumes he does not exceed 10 days of sick time. If this guy is a contractor and he works less than 40 hours, then we calculate the hourly wage, which will be, these guys will definitely underpaid because that guy is paid by an hour worked. And also the company policy requires that contractor to produce an absence report to explain why he was not at work or why he was not working 40 hours. When the working week is normal 40 hours, then this salaried employee is getting his or her pay, and the contractor is getting paid by the hourly wage as usual. However, if both employees worked overtime, the poor salaried employees still got his base pay. He did not get any overtime because most of the salaried employees are exempt from overtime. So no matter how much you work, you don't get paid extra. And this contractor is a lucky guy because he got paid overtime, and it will be calculated based on the overall number of hours worked. So by having this table composed and nicely outlined like here, you can easily categorize your tests and put them in some system that you cover each and every combination.
So testers do the table?
It depends actually. In my experience, testers did the tables, but sometimes developers themselves cannot define the algorithm of this. They need to understand what the requirements are, in which case they may request business analysts or marketing people to do the table. Or maybe developers can do the table. It doesn't actually matter as long as you have it. Yeah. One more technique is the state transitional diagrams. Again, I have a very simplified example, and you can Google, you will find more. But for this transitional diagram, I have a ticket reservation system. So this methodology is very useful when you have softwares or applications which are flow-like, which some applications, softwares that require, users to follow through some flows. Shopping cart applications, reservation systems are very good examples of it. You start your diagram with a starting point, which is this black dot here. And this diagram is written in terms of applications. So these circles are states, and these lines are transitions between the states. So when you start your testing activity, you need to make a reservation. So your reservation goes from null point, 0 point, to the made state. You make a reservation, your reservation goes into made state. From this state, you have two ways to go. One, you can cancel the reservation, and then this reservation goes into canceled state. Or, if you like a reservation and if everything suits you, you pay money and the reservation goes into paid state. If you're lucky from this, if the application allows you to cancel your reservation because it was not yet used, then from this point you can go into two states. One is the canceled state, again if you cancel at this point. And if this system allows to print paper tickets, you can go and print your tickets. In which case, your reservation, goes into ticketed state. From the ticketed state, you can happily go to your vacation and use the ticket, and then your reservation goes into use state. Or you can cancel your reservation if you're lucky, if software allows to do that, but in my example it does allow you to do that. And then from ticketed state, you go into canceled state. The logic, when you write test cases for these flows, the idea is, I think I put it in here. No. So the idea is basically to test each and every state and each and every line at least once. This way you will go through each code path at least once. Now, by looking at this diagram, tell me how many test cases you would create.
One per link, one per state.
Okay, one per link, one per state. What other answers do we have?
I mean, high-level test cases.
High-level test cases.
12.
12. One? No. One, no. One, no good. 12? 5? 12? Any more opinions?
11.
11. Sold. No, I'm kidding. Actually, okay, it all depends on what we define as a test case, right? If I was writing those test cases, I would probably cover it with 4 test cases because those are flow-based. So what I said that each arrow and each circle needs to be covered once, but I didn't say that you cannot cover the same circle of flow twice. There are some, because of the flow-based scenarios, you cannot arrive to this state unless you go through some others, right? So it all depends on what you call a test case. Remember I was talking about wizards? I told you that you can write test cases for each and every page on the wizard. In this case, yes, you will have 11. 11? 1, 2, 3, 4, 5. 6,
No.
7. No?
The first link, you don't need the first link. You need just the first
okay.
state.
Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, 11 test cases, right?
Yeah.
But if you want to simplify your test case design and optimize it, so the optimization part of it is that you run only 4 test cases. You write 4 test cases and, okay, you start here, you cannot avoid it, right? You start fresh, clean from this 0 point. You go, you make the reservation, and then you cancel it. This is your test case number 1. It is flow-based. It will be a lengthy test case maybe, lengthier than just 2 single test cases. But it will optimize your design because you don't have to maintain the setup part for this case, right? You cannot go to cancel until you've been into made state. So then your second test case would be 0 to made to paid to cancel. Your test case number 2, made, paid, ticketed, cancel. Number 3, made, paid, ticketed, used. 4. You can have 4 flow-based test cases and provide the same coverage as with 11 non-flow based test cases. It's up to you, as I said. It is something that people do in the field. And again, it depends on how test cases are done, whether they are automated or not, and who will be running those test cases. Risk analysis. Okay, risk analysis, strictly speaking, it is not a test methodology, but this is something that people do use in the field when they need to deal with the aggressive timelines and insufficient resources. Let me give you an example. Remember that beautiful chart that we had where we started on January 1st and we said we need, for example, 4 or 5 cycles, let's say 4 cycles, and then maybe once the quality improves. And by the way, the first few cycles are usually called phase 1 or alpha testing, where we just test the software, but it has not yet reached the definite maturity point. So this all may be our alpha testing. And then at some point, we may enter beta phase. Beta phase is actually we are running through the same tests, usually or maybe some major subset of the regular tests. And the difference between alpha and beta is that beta quality software usually has a higher quality. So the beta criteria to go into beta phase, your software has to reach particular execution rate and pass rate. Usually pass rate is 75–80% of your test cases should pass, then you can enter beta. In beta stage, you also run a few cycles, the bugs are getting fixed, you're getting new builds, and then eventually you receive the final candidate build, the release build, which will be released. You run 1 or 2 cycles here, and you're done. This is happy picture, right? You requested, let's say, 1, 2, 3, 4, 5 cycles in your alpha phase, 3 cycles in your beta, and 2 cycles in your final cycle. Final phase. And originally project management said, yes guys, of course you have this time and everything looks happy. What happens if developers delay the delivery of the first build? That was the plan, right? On January 1st we get the first build and then we go with this plan. What happens oftentimes, and each cycle is 5 weeks. What happens oftentimes, let's say they had some technical obstacles. They started some sanity testing on their own and they realized the prototype doesn't scale well, or something else happened. In this case, they will delay this beginning of the testing phase. Let's say they will deliver it to you on February 15th. And our release date was, let's say, almost a year from now, let's say December 1st. If the beginning of the testing phase was moved to February 15th, does it automatically mean that the release date will be moved? No. No. And then, what we'll have to do on the QA side, I mean, we have few choices. First of all, we can whine and complain and be unhappy because we are being stressed and we didn't get whatever we were promised, right? It's like you go for shopping and you pay or you expect some clothing to be there and it's not there, and you're unhappy. This is choice number 1. Not a good choice, can tell you right away. So second choice is you can prioritize your testing. And this is where risk analysis is very helpful. So you can use risk analysis to prioritize your testing when you're done already with your test cases, or you can even use it when you create your test cases. You can use risk analysis to prioritize the features in your software to start writing test cases for the most important areas. And for you can also use risk analysis to analyze the bugs. you can start back analysis from the most important features. How you run risk analysis? You basically take the documentation for your software product and you make this table. This is a simplified version again. There are more complex versions, but this is very simplistic, but I've used it and it worked very well for me and in my practice. So you make the first column a feature list. Basically, you take all the features in your product and you put them in this column. So each feature is a new line in your table, new row in your table. How granular you will go is up to you. You can go on a high level, log in, create database record, modify database record, delete database record. You can go more deeply into details, up to you. I recommend to keep it high level just because when you work on this document, you will need inputs from different people and not all of those people know all the details. For example, when you talk to marketing people, they may not even get into all the details, but terms login, create, and modify, they do understand. So again, it's up to you, and I suggest you keep it high level. Then, you need for each feature, you need two pieces of information. You need two pieces of data. One is likelihood of failure. So what is likelihood of failure? And this is the probability of an event occurring. For example, it is the likelihood that the user will make a mistake, and if a mistake is made, the likelihood that will go undetected by the software. So basically, likelihood is the number, and this number can be given on any scale. You can use scale 1 to 3, 1 to 5, 1 to 10, up to you again. The only thing, it has to be consistent for all the features and for all the columns in your table. So basically, when you ask people to evaluate the likelihood of failure for each feature, you are asking them how likely they think this feature will fail when used by the customers. For example, you go and the people from whom you get these inputs are QA, engineering, tech support. Those are the people who know tech support. They work with customers, so they take support calls. They have some historical data. They know which features are historically failing for this company. Development, believe me, they may not tell you, but they will know their code very well. They may not tell you, I wrote faulty code, but you put them, ask them to fill this table. They will be honest because they understand, if they are honest here, eventually those areas will be tested more thoroughly and more bugs will be found. The quality will improve. So you ask people to put these numbers in, and you can talk to 10, 5, 15 different people. Depends how many you can find. And each person will give you his or her own number. Again, use a simplified scale. After you get 5 replies from 5 different people or 10 replies from 10 different people, calculate the average and put it in this table. So for each feature, you will have this average number from multiple people from multiple teams certifying the likelihood of failure. At this point, this number is very subjective, but it is better than your own guess because this is average number across multiple people, many people, multiple opinions. Second piece of data that you need for each feature is the impact of failure. So basically, you talk to a different set of people. You talk to product management, tech support, sales, QA, and you come to those people and you ask them, okay, now tell me, on a scale 1 to 3, 1 to 5, 1 to 10, whatever the scale is, tell me if the feature fails, how bad it is. See, it is very different, it is parallel to the likelihood of failure. So basically here you are asking them how likely you think the feature will fail. Here you are saying, if it eventually fails, how bad it is. 10 being the worst. And of course, if login fails, it is 10 out of 10. Because if login fails, you cannot do anything with your application. So, and so forth. You will have, again, multiple numbers from different people. You make an average, you calculate the average. And at the end, what you do, You multiply those two numbers, what you get in this column is so-called risk factor. So you will have all your features ranked by the risk factor, and the rule is features with a higher risk factor require more attention. Which means if you don't have enough time because developers didn't do their job in time or for whatever technical reasoning is behind it, you start your testing, you start your test case design, or you start your test execution from the areas which have higher priorities. And then you go down the list. So basically, once you're done with all the risk factors, you sort by this column, and then you go in the sequence. Whatever you get, whatever the sequence you get after you sorted your features. So any questions?
Guys, I will comment. I mean, first of all, you have a question on the risk analysis, and we've got, amazing answer right now. I think you appreciate that. Another thing I want to kind of remind you about. Normally, if you get a contract, and term of contract is like typical, it's like 3 to 6 months. Doesn't mean much, but okay, 3 to 6 months. And when they hire you, normally on a contract is where when release, the development lifecycle moves from alpha to beta, somewhere. And then what happens, that story with delayed and more delayed and even more delayed, testing, and the release date being the same, it results in lots of overtime. And that is why when you look at the job descriptions, here we come to the job market, when you look at the job description and it says 3 to 6 months, and then it says JavaScript, PHP, Selenium, this and that, guys, it's all bullshit. Because there is no time for the crap, okay? What happens, it's severe overtime with just manual monkey testing. Okay, because they have no time, statistically, maybe 90% of what you're gonna face is that. And the story actually shows you what really happens and why it happens. And the situation with delay, you are unlucky, but you are typical. It's amazing to see, the timeline to be perfectly done. Guys, it doesn't happen. It will go that way. We are talking about waterfall. We are not talking about agile. Agile is a kind of legal disaster.
It's very different, yeah. So, and to add to what Michael is saying, basically this picture with when the job posting is being posted on the internet or wherever, the manager usually didn't even start the testing yet, right? So he's at the planning phase. He thinks that he will have 11 months to test the software. That's why all these Java, Perl, whatever requirements come in. And all the interview process is happening at that point. The manager thinks and wants very badly to use automation because it is efficient when it is when it is written in the right way, and it is very popular. Everyone is doing automation, but I can tell you on my own experience, if it is written in a bad way, it is a disaster like there is no tomorrow. So, but manager may not necessarily understand that. So he or she thinks, okay, I need that person who knows. And plus, oftentimes, at the planning phase, developers are still deciding whether they want to use Java or C# or C++ or something else to write the UI. Which means the choice of the UI automation tool is not even done yet. But manager is trying to put as many requirements into the job description. So finally he can catch golden fish, and that golden fish would know everything about everything. So this is not happening in real life. I've been in those positions. I used to be manager for like 4 months. It was the worst time of my life. And I was supposed to hire a person as a replacement to my previous manager. That was a whole, enchilada, but doesn't matter. So I've been in those shoes, and I know how all is done. So you plan something, you are not sure whether you need this or that or something else. Just in case, you put everything in the job description and you give it to the, because even now, being 10 years or 11 years in the QA industry, I read some job descriptions and I realize that I will never fit into this. Because if you're hard working, if you're a worker bee at some company, you can be perfect silk expert, but you may not know Perl. Because if you're focusing on the UI automation, you really work with silk or some UI, oriented tools. You do not touch Perl. I mean, I'm a perfect automation engineer. I'm leading automation group. I'm not an expert in Perl at all. If someone asks me to do Perl, what I do, I Google, and then I struggle, and then eventually I will write something. But it's not, I don't have this knowledge on the top of my head. Same is happening everywhere. So people want to have everything just because of this uncertainty. They don't know they know that they will have, some time, probably not as much as they promised or as much as they request, and they will have to somehow shrink the testing time, so they're trying to use automation, and then by the time automation is supposed to be developed, UI is changing all the time, so you cannot write the automation, and and we eventually end up by doing manual testing all the time, and over time, and all.
Which is why automation is a good area. I mean, they pay you money, more than manual, and you're not responsible for anything because UI is changing anyway. So,
yeah, it's a continuous process. You get a good pay, and yeah. So some companies actually bypass it by having manual group and automation group. And then automation group is kind of those cool guys who do not write test cases. They take test cases written by poor manual guys, and they just automate it. And if UI is changing, they keep automating and they don't struggle. They're just automating for the future releases, because there is no way you can have this automation pay you back on the first release. There is no way, unless you have 3 years test cycle, which will never happen these times. So this is how life goes. Okay, we have 15 minutes left. I have one more item I want to highlight with you guys, and this is Traceability Matrix.
yes.
So this Traceability Matrix, it is a document which I personally found very useful. It is not rocket science, it's very simple. It is basically, okay, first of all, what it is. It is a document which tracks each software feature from PRD, which is requirements document, to functional specification, to test documentation, which are test plans and test cases and test suites. Who are the people who develop and maintain this document? Those are engineers and QA. Usually it is developers start creating the traceability matrix, because traceability matrix starts from mapping PRD to functional spec. But if developers cannot do this, we QA usually do this. It's not a big deal. It won't take you a long time, but it will pay you back on a big scale. When we start this traceability matrix, we can start it at the design phase, coding, testing stages. It's still fine, because this document actually is making sure that you have proper coverage, right? You take each feature from PRD, you go to functional spec and test cases. So as long as you can understand that you have coverage for each and every feature across your test cases, you're good. What we do, we analyze this document for completeness. Of course, we contribute and develop this document. We make sure each feature is represented. And if there are any gaps, we highlight those gaps and we have them covered. This is a very rough example of traceability matrix. And again, any format can be used. Excel is good, Word is good, any table format is good. You take your PRD sections and put them in this table. Each feature in the, each requirement in the PRD document is one cell here. Then what you do, and again the level of granularity is up to you, but usually it goes by PRD section. So if you have 2 digits in your section numbers like 1112, you go with that. If you have 111, 112, you go with that. So you take PRD sections exactly the way they are. And then you open functional specification, and you find for each PRD requirement listed here, you find the corresponding section in the functional specification. Same requirement can be covered in more than one functional specification section. So usually the traceability matrices, they go like this. Okay, these are the requirements, PRD, this is the functional spec, and these are the test cases for test suites. Test suite is a collection of tests, so just a set. For example, by functional area. Login test cases, shopping cart test cases, something else test cases. So in the PRD you have just one requirement. In the functional spec you may have two sections covering the same requirement, and most likely you will have multiple test cases or test sections covering each of the functional spec sections. So you map functional spec sections for each requirement, and then you go and map your test cases per specification section. Is it clear how it goes? So it eventually goes, it takes this tree like shape. And here you may have three.
Just want to mention there are tools which automatically convert requirements into test cases, and they claim, I'm not sure, but they claim it's like 20-25% of test cases will be automatically generated. But what's important, when you change requirement, it immediately tells you how much work is behind, and sometimes they don't change because it's too much of other things involved.
Yep.
So that kind of
Yeah. And it also depends how requirements are written and which terminology is used, because sometimes developers and marketing people, they may use different terminology for the same thing, and then those tools may have troubles mapping one items to other items. But again, those tools do exist, and some companies do use them, but I'm a control freak, so I always do it manually. So it's up to you. And actually, it's up to the company also, because if company cannot afford those tools, then you'll have to do it manually. But it is very useful technique, because it does give you the this ability to review your entire coverage, all the requirements. And of course, there may be cases where you find some requirements not covered. By the way, if you find some requirements not covered, what do you do? You can exclaim loudly, crying, guys, we have a test gap, we have a test gap. But before you do that, go to marketing people and check if that requirement is still valid. Because oftentimes what happens, the requirement was dropped from active development for whatever reason, and this PRD document was not updated. So before you start panicking, check with the development and check with marketing people. And if you find out that the requirement was dropped, and that's why it does not have any representation in the functional spec and in any of the test cases, then ask product management to update the requirement document. Then everything will be aligned. You don't have.
I just want to mention the danger of going outside of your team. So if you really want to go to marketing, so make sure you're allowed to, because lots of problems are arising out of the fact people go outside and kind of undermine the positioning of their management.
Yeah, so there is some angle of politics involved always, unfortunately, and there are some companies where there is very strict regulation on where you can go with what questions. Of course, once you are there for like few weeks, you will know. You will have this feeling. There may be practices where only QA lead will be gathering all the questions and going, serving as a connection between development, QA, product marketing. But actually, I prefer open connections where you can talk to anyone. But it may depend, Also, sometimes what happens, product marketing, the marketing people are usually busy. They're always somewhere out there in the conferences, and if, let's say, the guy or the lady who is managing your product from product management perspective holds a very high position in the company chain, it may not be appropriate for you to run to that person with each and every question. In which case, I highly recommend you do talk to your lead or manager with all the concerns that you have, or if you work on the traceability matrix and you have some questions, summarize everything from everyone in one document, and then circulate that document instead of running back and forth for each and every question that you have. So this concludes everything I wanted to tell you guys today. Do you have any questions? We still have like a few minutes, 6 minutes.
So I would, going back to the whole idea of overtime, I would imagine that like the larger companies want to avoid that whole deadline, deliverables, panic, fire drill mode, but that still goes on regardless? Okay.
No, it actually depends, because sometimes if you can mitigate these risks, again, experienced QA managers, especially if they are in this company for like a few years, maybe a year or two already, and then there is yet another project starting, they have this feeling, they know how much they should request for, in terms of time. So they may request, they know they need only 6 weeks, but they will request 8 or 10 to test the software. Just because they know developers will be late anyway, so if they are late for 2 weeks, then we'll still be okay, QA-wise. And if they're in time, we'll finish the testing early and everyone will get rewarded. So that's what I'm saying. There is always this little bit of politics, to everything that happens between QA and development and all this software management process. But generally, yes, overtimes are very possible, and also because sometimes you work and work hard and you do everything you think you should do and you are doing everything right, and then in the latest moment someone finds a critical bug, or and then you have to retest the whole thing again. And let's say you prioritized everything and you found some subset of your tests that you would be comfortable with rerunning, and it's not going to happen. You need to rerun whole enchilada again just because there was a critical bug found. And this is where everyone gets squeezed. But it depends on a particular situation. It's part of the job, and you just take it.
And more likely in startups as opposed to somebody like VMware?
I wouldn't say that, because we've been I'm with this company for 4 years. The first 2 years, 3 years actually, it was a constant overtime struggle. Just because we had a very complex product, now it is matured enough, so it can be released, with a less effort from QA side. But prior to that, it was constant, overtime.
Can you give a definition of overtime, like what, 16 hours per day, 12, 10?
Now, strictly speaking, anything that requires you to work more than 40 hours a week is overtime.
I understand.
But reasonably, what happened in my practice, we used to have 12-hour working days, for a few months in a row. And that was very exhausting. But this is not typical. I think as a full-time, contractors are in a lucky position, because for contractors, if you work overtime, you will get paid for that. If you are a full-time employee, think about 9 to 10 hours working days. Yeah.
It also depends where you are on the skill level. So, for example, my first job, I was working from 8 a.m. till maybe 9, 10 p.m. every day. And I was actually considering myself lucky, so I can practice and learn more. And then my second one was pretty much, it was maybe 8 a.m., 11 p.m., and one day I came home 8 a.m. next day. And so it was a startup and just survival kind of thing. And then,
But what I can tell you from my experiences, when you work overtime, especially in the off hours, let's say if you are sitting in the office, with VMware we are lucky we can work from home, which is very helpful. So you still work, but you can lie on your couch and just do something and watch some movie, and then do something and watch some movie. But if you're in the office and there are other people in the office at the same time as you, it gives you this unique feeling of teamwork eventually. It is very rewarding, I can tell you, because you feel this shoulder to shoulder, things, and night conversations, are very rewarding as well. So I did enjoy it. It was stressful, but in some weird way, I did enjoy it. So I cannot complain. And overall, VMware is a great company. Unfortunately, we don't take too much interns, right? We don't take too many
We were
interns.
just about to, but it was actually signed. They were, yeah, but then
someone purchased someone and then stock went down and
Oh,
changed a
yeah,
couple
yeah,
of years
yeah.
ago.
We just acquired another company today.
Okay.
Yeah, but anyway. Okay, thank you guys. It's been a great class.